Imagine a world powered by the sun, a clean, inexhaustible source of energy. This isn't just a dream or a distant possibility, it's a vision that is rapidly becoming our reality. Solar energy, derived from the radiant light and heat of the sun, is one of the most promising renewable energy sources available to us today. It has the potential to revolutionize the way we power our lives, offering a sustainable and environmentally friendly alternative to traditional fossil fuels. This vision is becoming a reality thanks to solar panels, devices that convert sunlight directly into electricity. These panels, made up of photovoltaic cells, capture sunlight and transform it into usable electrical energy. The process is both fascinating and efficient, allowing us to harness the sun's power in a way that is both practical and beneficial for the environment. As more and more homes and businesses adopt solar technology, we are witnessing a significant shift towards cleaner energy solutions. Solar energy offers a sustainable alternative to fossil fuels, combating climate change and reducing our reliance on finite resources. Unlike coal, oil, and natural gas, solar energy is abundant and renewable. It produces no harmful emissions, making it a key player in the fight against global warming. By investing in solar technology, we are not only reducing our carbon footprint, but also ensuring a more stable and secure energy future for generations to come. As we delve into the fascinating world of solar panel manufacturing, we'll discover how these devices capture the sun's energy and transform it into power for our homes, businesses, and beyond. The manufacturing process involves cutting-edge technology and meticulous craftsmanship. From the creation of the photovoltaic cells to the assembly of the panels, each step is crucial in ensuring the efficiency and durability of the final product. This intricate process highlights the incredible innovation and dedication that goes into making solar energy accessible to all. Solar panels represent a remarkable feat of engineering, harnessing the fundamental principles of physics to capture energy that has sustained life on Earth for billions of years. The sun, our closest star, has been a constant source of energy, driving the processes that make life possible. By tapping into this vast and powerful resource, we are able to generate electricity in a way that is both sustainable and efficient. The technology behind solar panels continues to evolve, with advancements that improve their performance and reduce their cost, making solar energy more accessible to everyone. By understanding the science behind solar energy conversion, the intricate manufacturing process, and the diverse applications of this technology, we gain a deeper appreciation for the vital role solar panels play in shaping a sustainable future. Solar panels are not just limited to rooftops and solar farms, they are being integrated into various aspects of our daily lives. From powering remote villages to providing energy for urban infrastructure, the applications of solar technology are vast and varied. This versatility underscores the importance of continued research and development in the field of solar energy. Let's embark on a journey to uncover the secrets of these remarkable devices and explore how they are illuminating the path towards a brighter, cleaner tomorrow. As we delve deeper into the world of solar energy, we will discover the incredible potential it holds for transforming our energy landscape. Together, we can embrace this renewable resource and work towards a future where clean, sustainable energy is available to all. Join us as we explore the innovations, challenges, and triumphs of solar energy and learn how we can all contribute to a greener, more sustainable world.
At the heart of solar energy conversion lies a fascinating interplay of light and matter. This process is not just a simple interaction, but a complex dance that has been harnessed by human ingenuity to create a sustainable energy source. Sunlight, composed of tiny energy packets called photons, travels millions of miles from the sun to Earth. These photons carry energy from the sun, traversing the vacuum of space at the speed of light, taking about 8 minutes and 20 seconds to reach our planet. When these photons strike a solar panel, they interact with its key component, silicon, a semiconductor material. Silicon is chosen for its unique properties that make it ideal for converting light into electricity. Silicon's atomic structure allows it to absorb photons, transferring their energy to electrons within the material. This absorption process is crucial as it sets the stage for the generation of electricity. This energy boost liberates electrons from their atoms, creating a flow of electric charge, the very essence of electricity. These free electrons are then able to move through the material, creating an electric current. By strategically layering silicon and incorporating impurities through a process called doping, solar cells create an electric field that directs the flow of these energized electrons, generating direct current electricity. Doping involves adding small amounts of other elements to the silicon to enhance its electrical properties. This elegant process, known as the photovoltaic effect, forms the foundation of solar energy technology. The photovoltaic effect is a phenomenon that was first observed in the 19th century and has since been refined and optimized for modern use. It's a testament to human ingenuity, harnessing the fundamental laws of physics to convert sunlight into a usable form of energy. This technology has evolved over the years, becoming more efficient and cost-effective, making solar energy a viable option for powering homes and businesses. Understanding this process allows us to appreciate the complexity and elegance of solar panels, marveling at their ability to transform something as intangible as sunlight into the power that fuels our modern world. As we continue to innovate and improve solar technology, we move closer to a future where clean, renewable energy is the norm, reducing our reliance on fossil fuels and helping to protect our planet for future generations.
The journey of a solar panel begins with raw materials, primarily silicon, the second most abundant element on Earth. Found in sand, quartz, and even some plants, silicon's abundance makes it an ideal candidate for large-scale solar energy production. Extracting silicon from its natural sources involves a series of chemical reactions and purification processes. Once refined, silicon takes the form of a silvery gray, brittle material ready to be transformed into the heart of a solar cell. Beyond silicon, solar panel manufacturing requires a variety of other materials, each playing a crucial role in the panel's functionality and durability. These materials include glass for protection, metals for conductivity, polymers for encapsulation, and specialized coatings to enhance light absorption and prevent energy loss. Sourcing these materials responsibly and minimizing environmental impact throughout the supply chain are crucial considerations for ensuring the sustainability of solar energy production. From silicon mines to specialized material manufacturers, a global network of industries contributes to bringing the essential ingredients of solar panels together.
Transforming raw silicon into the high-purity material required for solar cells is a multi-step process requiring precision and expertise. This journey begins with the extraction of silicon from its natural state, often found in the form of silica or silicon dioxide. The raw silicon is then transported to specialized facilities where it undergoes a series of complex procedures to achieve the desired purity levels. The journey begins with melting silica, or silicon dioxide, in a furnace at extremely high temperatures, reaching over 1,700 degrees Celsius. This intense heat is necessary to break down the molecular structure of the silica, allowing the silicon atoms to separate from the oxygen atoms. The process is carefully monitored to ensure that the temperature remains consistent, as any fluctuations could affect the quality of the final product. This molten silicon undergoes a chemical reaction, removing oxygen and leaving behind purified silicon. The removal of oxygen is a critical step, as any remaining impurities could compromise the efficiency of the solar cells. The purified silicon is then allowed to cool and solidify, forming a solid mass that can be further processed. Through a crystallization process, the purified silicon is grown into large, cylindrical ingots, resembling giant metallic crayons. This process involves carefully controlling the cooling rate to ensure that the silicon atoms arrange themselves into a uniform crystal structure. The resulting ingots are incredibly pure and possess the ideal properties for use in solar cells. These ingots, weighing hundreds of kilograms, represent the culmination of significant energy and expertise, embodying the transition from raw material to high-tech component. Handling these massive ingots requires specialized equipment and skilled workers, as even the slightest mishandling could result in damage to the precious material. The next stage involves slicing these ingots into thin, wafer-thin sheets using specialized saws. This process, known as wafering, is incredibly precise and requires advanced machinery to achieve the desired thickness. The saws used are equipped with diamond-tipped blades, capable of cutting through the hard silicon with minimal waste. These wafers, typically less than 200 micrometers thick, form the foundation of individual solar cells. Each wafer is meticulously inspected to ensure that it meets the stringent quality standards required for solar cell production. Any defects or irregularities are identified and addressed before the wafers move on to the next stage of production. The precision and care taken during slicing are crucial, as any imperfections or cracks can impact the cell's efficiency and overall performance. Quality control measures are in place to detect and rectify any issues, ensuring that only the highest quality wafers are used in the final product. This attention to detail is what sets high-performance solar cells apart from their lower-quality counterparts. The transformation from sand to silicon wafer is a testament to human ingenuity, turning an abundant natural resource into a precision-engineered component capable of harnessing the sun's energy. This process not only highlights the incredible advancements in materials science and engineering, but also underscores the importance of renewable energy in our quest for a sustainable future. The journey from raw silicon to a functional solar cell is a remarkable example of how technology can be harnessed to create solutions for some of the world's most pressing challenges.